All right, so this should be a little bit better. What's up? Yeah. Yep. Just have her like email me or something that you're there. All right. Okay. So the cool thing is with the area between curves, it doesn't matter if it's above the x-axis, on the x-axis, below the x-axis. Everything winds up working out. The area between curves will always be the integral from a to b, where a and b are the intersection points of the region where they're intersecting like that, or the area between them. It's going to be top minus bottom. This is, whoa, I can't spell. Bottom dx. Key issue here, so bad. Key issue here is that sometimes one's on the top, the other's on the bottom. Sometimes it's the other way around. The true formula, it's down here. The theorem states that it's going to be from a to b, f of x minus g of x dx. Key thing is that g is less than or equal to f of x for all x. So if that wasn't the case, we would need to switch g and f. But that's really it. So, for example, and this is the way we're going to do this is we're going to do a rough sketch and then set up our integral and then use the calculator. These are able to be done by hand, but we're at the point in the year where we also need to know how to do them in the calculator. So the first one, x squared plus 2, remember that's a parabola moved up 2. So it's like like that. And then y equals negative x is that line, so okay. So we want the region bounded by the graphs from 0 to 1. So that's going to be like this shaded in region. So if I want to find that, that one's on top. So all I got to do is go from 0 to 1, take x squared plus 2, and I'm going to subtract negative x dx. So it's top minus bottom, and all I got to do is drop this in. So from 0 to 1, and I should do one of these in the older school style that doesn't have the cool little formatting to remind you where everything goes. Because if that cool little formatting is not in there, it's a little bit harder to remember how to type things in. So I got 2.83, and remember we want 3 decimal places. So that's one way to do it. If your calculator is in the classic mode or doesn't have this, I know some of your calculators don't, I still go down here to the integral and I still type in my function. There's nothing different there. But here, so notice how there's this open parentheses at the very beginning. And then we said x squared plus 2, close it off, minus negative x. So this is still here, and that's going to be until the very end. So I don't want to close this off yet. I want to put a comma in and put my variable there. And then I'm going to do another comma. I'm going to put a. And then I'm doing another comma and put b. And then I'm going to close my big parentheses. So comma x, comma a, which is 0, comma b, which is 1, close it off, and now I got the exact same answer again. So, okay, let's keep going. So, Sophia, you better watch this because you were like, you're gonna videotape it, right? And I was like, no. And then you're like, come on. I was like, okay. So. All right, so x cubed minus 1. That's the one that goes like that, and it's moved down 1. So, but since it's just a plain old x cubed, it's not going to be as exaggerated as that. All right, it just took a phone call. So with this one, let's see, y equals 7. Remember, that's a horizontal line. X equals negative 2, that's a vertical line. So horizontal line at 7. I love how this is horizontal. The one's like going down like that. And then x equals negative 2. And then it says y equals x cubed minus 1. Wait, it doesn't tell us my bounds this time. So this time when I come in, It's going to look something like that. And you can always go to your calculator to get a slightly more defined picture on this. Let's see, x cubed minus 1. Oh, I want to change it back to the cool classic mode. I mean, math print mode. I like that more. So, oh, mine's all messed up. So I'm going to hit zoom standard. That was 6. Standard is 6. So, okay, so you can see that my drawing here, it's not too far off of the real thing. And we can see that this is my shaded region because this is the area bounded by those 3 curves and lines. So these are my points of intersection. Oh, so if I'm finding the area of this region from left to right, well, the left-hand side is here at x equals -2. So I know that I'm going to go from -2 to wherever this is. So we're going to have to find that. But then we can see that this is on top, and this is the line y equals 7, and this is underneath. So all I got to do is find out this bound right here. So to do that, we will say, oh, I need to know when 7 and x cubed minus 1 intersect. So hey, when does x cubed minus 1 intersect with 7? So I'm going to do this twice. I'm going to do this by hand once, and then I'll do it in the calculator again. So if I'm solving this, I can just add 1 to both sides, get x cubed is equal to 8. And then take the cube root of both sides and get x is equal to 2. So I am positive that 2 is the number, but if I was unsure how to do that by hand, I would pop over to my calculator and I'd go, I want to know when these two intersect. So then I'll do the second calc, and I'll go down to intersect, push enter on that. First curve, it's just asking, if you had more than 2 curves in here, you'd have to select which one. But since I only have 2, I just push enter. Likewise for second, and guess. If they touch more than once, you want to move it closer to the touching point, but it doesn't matter since it only touches once. And I got x is 2, y is 7. So when x is 2, y is 7, oh, so x is 2. 2. Boom. All right. So now all I need to do is take this integral and plug it into my calculator. And it might be one of those things where you feel like simplifying it first. It will not change the answer. So, okay. Let's see, I've got 7 is in y1 and x. All right, I want to show you one other trick that you can do when we're typing these in. I did not show this in class, but if I'm going from -2 to 2, I'm doing 7 minus that. 7's y1, right? So the cool little trick that you can do here is you can, when you're in here, if you go to vars and over to yvars and into function, I can literally say take y1, subtract vars function y2, where I had y1 was 7, y2 was x cubed minus 1. If I do that, still got to do dx at the end. Oh, it ended. So if we do that, it'll give us the answer. And if you don't believe me, let's just really quick. 7 and then x cubed minus 1. Also 32. So 32. All right, cool. So little trick for you. Let's see if we look at our next one. There's not a crazy amount of new calculus that we're going to do for the rest of this. It's just going to be different algebraic techniques. So x squared looks like this, but minus x squared looks like that. And then the 2 tells us to go up 2. So I've got a frowny face. I've got a y equals x. 2 intersection points. There's my region. So what I need to do is I need to find out my a and my b, and then do my parabola minus my x dx. Shouldn't be too bad. So we want to find our intersection points by saying 2 minus x squared is equal to x, and then solving that. So solving quadratics, we want to set it equal to 0. So I'll subtract 2 from both sides. I'll also add x squared to both sides. And so we'll get x squared plus x minus 2. So one way we could handle this is by remembering that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah, that's right, I sang a song. So we could use that, knowing that a is 1, b is 1, and c is negative 2. This is really annoying. I have no reason to do this because this actually factors, but I want to give you multiple approaches. So that'd be negative 1 plus or minus square root. That's going to be negative, or positive 1, sorry. Positive 1 squared minus 4 times 1 times negative 2 all over 2 times 1. So we got negative 1 plus or minus square root of, let's see, negative 4 times negative, that's positive 8. 1 plus 8 over 2. I think so. If you fill something out, I'll send you. Let's see, negative 1 plus or minus the square root of 9 over 2 is negative 1 plus or minus 3 over 2. So negative 1 plus 3 over 2, negative 1 minus 3 over 2. Let's see, negative 1 plus 3 is 2 over 2 is equal to 1. Negative 4 over 2 is equal to negative 2. So my two bounds are 1 and negative 2. Remember, you always want to go least to greatest. Hey, Dan. There it is.
Can I do some makeup work for Mr. Fur?
Yes, you may.
I'm gonna go back to his class.
Okay, just have him like email me or something that you're there. All right. So that's one way to find our bounds. Another way to find our bounds that I would prefer personally is, well, now that I'm here, this would factor to x plus 2 times x minus 1. And so this would get me that x is equal to negative 2. This would get me to x is equal to 1. Oh, hey, it's the exact same numbers as before. And you can also use this. So then it's just a matter of plugging it into our calculator, integrating, the end. I always want to skip this example because I'm like, okay, we're getting the idea of this, but very important. E to the x is a swoop, remember. Swoop. X equals negative 1. It's over here. This is y equals 8. It's up here. Aha, so this is my shaded region. So I know that my bounds will be negative 1 to... I did not just say a bad word, that was the bell. So we know that it's going to go from negative 1 to whatever this is, but we're not sure what this is yet. And so what we're going to have to do is we're going to have to say 8 is equal to e to the x. And we're going to have to use log rules here. And we can, since it's an e, we can ln both sides and get ln 8 is equal to x. And so we'll use ln 8. And then, let's see. The flat line is on top, so we'll do 8 minus e to the x dx. The integrals that we've been looking at, they're all possible to be done by hand, but yeah, that's what's going on. Oop, minor earthquake, sorry about that. So here we got f of x is on top, g of x is on bottom. So if we want to find this colored in region here, which I'm going to insist is very close looking, to like a bunny rabbit. It's like part bunny rabbit, part otter. Okay, so that's not actually there. So if we want to find this, here it's f is on top of g. So for this first part, it'd be the integral from 0 to 3 of f minus g. And then from 3 to 7, g winds up flipping over and being on top. So you can say it's 3 to 7 g minus f. And so we'd get a number, add them together. Hooray. Let's see. Find the area of the two intersecting regions when using the curves y equals sine x and cosine x. So sine of x, you may not remember this, but sine of x is a wave. So we got sine of x, which looks like, I'm going to zoom trig for this one. So it goes through the origin and then bounces up and down. And then similarly, cosine of x, instead of starting at the origin, has a y-intercept of 1 and then begins to bounce down and up. Let's see. Oops. So we're really looking for two of these regions. You may notice that these regions look symmetric or look identical to each other, just kind of flipped around. And you'd be right, because they are. And so I just need to find out when these bounds are equal to each other. I'm going to do that using the unit circle. And then I'll show you how to do that by kind of cheating. All right, I'm back. Sorry about that. Okay, so we will, if I'm doing this by hand, I know I can set them equal to each other. And that's really saying, okay, on my unit circle then, when is my x coordinate equal to my y coordinate? So at the top, left, bottom, and right, we got zeros and ones, but we never have the same number at the same time. Turns out the only time we have the same number both times are at the exact diagonals here, when we have our root 2 over 2. So the only time they're actually equal to each other is when they're both positive or when they're both negative. So this right here is at pi over 4. And remember that since that's a quarter, that's a quarter, so 1/4, 2/4, 3/4, 4/4, 5/4. This is 5 pi over 4. So I could say that this is pi over 4 right here, then this is 5 pi over 4 right here. And then if I really wanted, I could keep on going 5, 6, 7, 8, 9, and I could say that this is 9 pi over 4. But since these are going to be identical, I don't really need to do all that. So if I set up my integral, I could say from pi over 4 to 5 pi over 4, we've got, ooh, which one's going to be on top? That's sine. So sine x minus cosine x dx. And I could just do this times 2. And I could get my answer. So if I was going to do that in the calculator, I would go in and I'd say, let me do the integral from pi over 4 to 5 pi over 4, and then do sine x. Oh, I think I need to double check something with my calculator. Minus cosine x dx. Before I hit enter, I am going to double check and make sure that my calculator is actually, yeah, my calculator was in degree mode. I'm going to switch it back to radian, because when we're in this, we're mainly dealing with radians. So now if I hit enter, I got that lovely number. Let me double it. So I got my area was 5.657. So we've discussed this in class a couple of times. I could write that, I could write this, I could write this. All three of these would be acceptable answers. If I wrote this, well, A, I rounded wrong, and B, why did I stop there? Nope, I got to go to 3 decimal places. Okay. Oh, just in case you don't believe me, So if we do that one, let's say we do that, and then we'll add it to a second integral from 5 pi over 4 to 9 pi over 4 of cosine x minus sine x dx. Push enter, wait for a while. Well, would you look at that? Okay, so, all right, we'll keep going. All right, find the area of the region bounded by these curves. Okay, these ones, I'm not 100% sure what these ones look like, so I'm actually going to go in and I'm going to zoom back to standard and try to graph them. So we got our x to the 4th minus 2x squared. All right, okay, for our next problem, oh yeah, sorry. I got to take a phone call. So here's an issue. With this calculator, you want to be careful. This doesn't say x to the 4th minus 2x squared. Like, that's not supposed to all be in the exponent. So be aware of that and make sure that you bring it back down after. All right, cool. And then we got our 2x plus 4. So we got our little curvy thing there, and then ka-chop. So we want that. It's going wee. Whoosh. So it's going to be that. So remember, I worked with some of you in class on this, and we were trying to solve it by hand, and no, it didn't work. If you were to try to solve this by hand and find the intersection points, you would wind up subtracting both of these and get them over on this side. But here's the issue. If we try factoring, like I take an x squared out of that, I get x squared minus 2. If I take a negative 2 out of that, I get x plus 2. Since these don't match, I can't continue factoring this by grouping. And I do not know a way to do this by grouping. And there's actually no formula that we can use to solve this. Brute force time. So I'm going to go in to second calc. I'm going to find the intersection point. So this is where you're going to have to get the cursor close to one of them. So first, second guess is right here. Oh, cool, it found that one. So my intersection was negative 1.54. I don't care about the y value, I care about the x value on this. So negative 1.54. And this is the kind of thing where I'm going to want to use the entire decimal. Wow. So negative 1.543689. Like, I want to use as much of that as I can because I don't want any round off error in the end. I want to be more accurate than I need to be. Then we'll find this one, and I believe this one's a nice one. So I'm gonna move the cursor over here. Sorry if I'm going extra fast today. I had double caffeine today. Yeah, it's a 2. And so, you know, it doesn't take a lot of effort to go from negative 1.543689 to 2, and then take your line minus your x to the 4th minus 2x squared. So let's just examine really quick what happens if you are not silly and putting in that whole amount. So I can do y2 minus y1, save myself a little bit of time. So I'm going to do that. Yep, another phone call. Okay, I may have just off camera typed something in while I was on the phone, sorry. So, oops, no, vars, y-vars function, y1, okay. So let me just double check. y2 was the 2x plus 4, y1 was that one. Yep, good to go. So if I do that, almost forgot to type the dx, it spits that out because I forgot to type dx. So I got 15.424. So let's see what happens if I just go in and am just putting these 3 decimal places. So it didn't start affecting it until down here. But that's not a risk I'm willing to take. And let's say that we rounded this, as a lot of people would be prone to do, and round it to 5, 4, 4. Okay, shut up. So it did not matter here. That's not a risk I'm willing to take. If you're willing to take that risk, no judgment, but take the extra 2 seconds and type the whole thing. Because if it ever does matter, then you'll be in better shape. All right, okay, we got 2 more. All right. So this time, and again, I don't know what that looks like off the top of my head, so I'm gonna just immediately resort to my calculator. Would have made sense to draw the line too. Okay, yeah, all right. So check it. We have 2 separate regions this time. We have this one, and then we have this one. And I don't care that my picture's really bad, because the thing that I care most about is being able to label these 3 points. So when we go in, I'll do my intersect. You know what, let me just try really quick and see if I can factor this by grouping. X cubed minus 4x squared needs to be equal to x minus 2. So x cubed minus 4x squared minus x minus 2. Yeah, no, it's not going to work. Because on this one, when I take an x squared out, I get x minus 4. That's a 2, so. All right. So yeah, I'm going to use my calculator. And my first curve, so I'm going to get really close to this first intersection point. So I got negative 0.76155572. Then I'll do it again. Then I got 0.63667176. Then we get 4.1248854. So I'm doing this really just to prevent any rounding off problems that I might have. So let's see. I entered this one into Y1, this one into Y2. So, let's talk about something legal that you can do on these. You can legitimately go, I could say that this is equal to A, I could say that this is equal to B, and I could say that this is equal to C. And since this is labeled as f of x and this is labeled as g of x, I could literally say from A to B, I'm too excited about this. I could literally say from A to B, curvy thing minus line, so I could say g of x minus f of x dx, and then I could add that to from B to C, f of x minus g of x. This is completely legal to write that. Go here, type it in, get the answer. They would give you full credit for this. Because all of these are labeled, all these are identified. They said, what's G? Oh, it's up there. What's A? Oh, it's right there. So, and if you want to be extra fancy, which I'm going to be right now, I'm going to say negative 0.76155572. I'm going to use a special feature. I'm going to push this STO. Let's push this STO button. I'm going to store that as A. So now anytime I press alpha A, my phone goes off. Now, every time I press alpha A, it's going to spit that number out. Similarly, I'm going to take this 0.63667176. I'm going to store that as B. And then I'm going to take 4.1248854, store that as C. And so now literally all I've got to do is essentially take this. So I go integral from A to B, drop in my, let's see, this one's y1 minus y2. Dx, and I'll add that to my integral from B to C. This time it's y2 minus y1. There's somebody at the door.
You didn't want to tell me I left my water bottle in here, Canfield?
Of course I didn't, Lacey. I didn't know whose it was. And so I got 24.136. Yay! Okay, so those little calculator tricks, I want you guys to be able to do them. You never have to, ever. So, all right, Find the region bounded by the area y squared minus 4. Yikes. So, if you can think about that, if it was x squared, it'd be a parabola like this moved down 4. Since it's y squared, it's going to be a sideways parabola moved left. And then y minus 1, I honestly have a harder time thinking about. So I know x is equal to y minus 1, so I could it's the same as y equals x plus 1. I'll add the 1 to both sides. So then I know it's going to look like this. And so the bounded region is going to be like this. So if I'm trying to do the area between curves on this one, but I'm using these y things, I know it's going to be from A to B, from my low to my high. Oh, sorry, no, when we talk about the y values as C and D to kind of remind us that we're using y values. And it looks like the line is on top, y minus 1 minus our curve. You said you want me to explain this? Okay, sure. Well, remember how like on the x1, like if we were looking from left to right, we would go, oh, well, this one's top, this one's bottom, subtract them. But now we're going from like low to high. We want to go, okay, which one's farther to the right? That's like our top, since we're dealing with y value stuff. So we would do farther to the right minus farther to the left. If you do it backwards, you'll see you get a negative answer. But so let's find these intersection points. This one I actually can do by hand. Y minus 1 is equal to y squared minus 4. I can subtract the y and add the 1 and get y squared minus y minus 3. Oh, but I don't have, this doesn't factor. Womp womp. So I'm just going to cheat. I'm not going to do the quadratic formula because I don't care. No, fine. All right. 1 plus or minus the square root of 1 minus 4 times 1 times negative 3 all over 2. So that's 12. That's the square root of 13. So that's 1 plus or minus the square root of 13 over 2. So if I'm going to be exact here, one of my bounds is going to be 1 plus root 13 over 2. And this one's going to be 1 minus root 13 over 2. Jazz hands. I can type all that in and spit out a number. Oh, I'm sorry. Let's get it. Don't need to be apathetic. So again, I think this is a good situation. We're saying 1 plus square root of 13 then divided by 2, and I'll store that as since that's the top, I'll store that as D. Oops. So I'll push the little store, and it'll actually, oh no, I wanted to say answer store as D, so I'll do second answer stored as D. And then I'll do 1 minus square root of 13 divided by 2, and I'll store that as C. So now I should be able to do my integral from C to D. of y minus 1 minus y squared minus 4 dy. And instead of typing all these y's like I did, you could have just used x's when you typed it into your calculator, like x minus 1. That would still work. But I got 7.812. All right. So, very long story short, make a sketch, set up the integrals by hand, and then use your calculator. Please like, share, subscribe, and please support me on Patreon.